Hey there, in today's video we're going to be talking about earthquakes.
Don't forget to smash that like button before we begin.
Earthquakes usually happen along the boundaries of tectonic plates. These plates are pieces of Earth's lithosphere that slowly move and sometimes grind against each other. When they don't move smoothly, friction builds up and causes stress. Eventually the rocks can't hold the stress anymore and suddenly slip, releasing a lot of energy. This energy travels through the Earth's interior as seismic waves, causing the ground to shake. The place under the surface where the earthquake starts is called the focus, and the point directly above it on the surface is called the epicenter.
A key tool to use to measure earthquakes are the seismographs.
A seismograph is a scientific instrument used to detect and record vibrations in the Earth's surface, especially during earthquakes. It works by having a heavy weight suspended above a base that moves with the ground. When the Earth shakes, the base moves, but the weight stays mostly still due to the inertia. This difference in motion is recorded on paper or digitally, creating a visual trace called a seismogram. Scientists use these to record to measure the strength, duration, and location of the earthquakes.
Good seismograph stations are placed away from cities so that traffic and heavy machinery don't interfere with the data. These false signals are called data pollution. Seismographs measure earthquake magnitude using the Richter scale, which increases by factors of 10. For example, a magnitude 4 earthquake is 10 times stronger than a 3, also meaning that a 5 magnitude earthquake would be 100 times stronger than a 3 magnitude earthquake.
Seismographs were developed to help us learn more about the Earth's interior, plate tectonics, and the structure of the crust. They help scientists figure out where and how deep an earthquake is. One of the best reasons for using a seismograph is for early warning systems. For example, in Mexico City, seismographs detect the first seismic waves and send alerts seconds before the strong shaking starts. This gives people a chance to evacuate, take cover, or stop dangerous equipment.
Seismographs also help emergency responders prepare and help faster. Because the earthquakes can cause millions of dollars in damages, having seismographs can help study past patterns and prepare for the future.
Seismographs are very effective and can detect different types of waves, including both lateral and deep seismic waves. They can create images of the lithosphere showing where rock layers are located or where large masses like underground gas or fuel might be. However, the technology also has some limitations. Seismographs collect a huge amount of data, which can be expensive to store and analyze. Processing this information takes time and requires high-performance computer hardware. The equipment itself is also more expensive than other similar tools.
Many indigenous stories also explain natural disasters like earthquakes. In one oral tradition, the earth was once covered in water. The creator asked the turtles to come out of the water to help form land. The creator put soil, trees, and plants on the turtles' backs. They became the land that we live on today.
But the turtles didn't always agree on who should carry the earth. They would argue and move, which should make the ground shake. This caused massive earthquakes. The turtles eventually agreed to stay still, but sometimes they still moved a little when they were tired, which caused more earthquakes. People learned from this to drop, cover, and hold during earthquakes.
This story teaches how earthquakes were understood before modern science and how people responded smartly and safely, even without technology.
Thanks
Thank you
for
for
listening,
listening,
and don't forget to
like and
smash that like button.